Hello everybody and welcome back to the DCAC channel, where in this series we solve technical interview questions. Let's pick a question, and I was looking at it. I think maximum number of balloons sounds interesting, kind of like goofy. Let's see, 1189, maximum number of balloons. Given a string, which would be text, you want to use the characters of text to form as many instances of the word balloon as possible. That's interesting. Let's see. You can use each character at most once. Return the maximum number of instances that can be formed. That is interesting. So I'm thinking about cases where regex could be something useful. I'm thinking about, I don't know, I guess we'll see. I'm not sure how to handle this, but I guess we'll see. So first example, this would be our text, and we can see that there are enough characters to form a single word balloon. How do you recognize there are enough characters? Well, that's an interesting thing, right? We could have something that's that's kind of like iterative, because we know if we don't find any B in the text, we know there is no possible chance to get the word balloon. If we don't find any, so basically we could have a mapping that would be required frequencies, and how do we do this? I mean, theoretically, we would have something like the character B would be at least once. That would be a requirement, right? And what would be for the character A? I wonder. All right, here's me forgetting to turn on my mic again. So let's quickly recap what I did here. Well, how we actually implemented this algorithm in the end was having a couple of interesting things. First of all, oh wow, what was that? Anyway, first of all, you have the required frequencies. What do they say? Well, they mean like that for each character in the word balloon, there is a frequency to that character, right? So we know that the letter A comes one time in the word balloon, the letter L you can find 2 times, and so forth. And those are necessary for what happens later. The gathered frequencies are all at 0 at the beginning, and they basically tell us how many times we saw this letter in our text. So we get max balloons, which is a variable. We'll actually look at that variable real quick afterwards. I'll actually put it a bit later on. This is always good to kind of like cluster things that are semantically or logically close actually together, because like if you have this way on top, why do you have it there, right? Like somebody starting to read this would be confused, like why are maximum balloons infinity, and later on they might even not have a good time trying to find it again when it's actually used. So keep it here where it's actually used. Let's go over the first part of this algorithm though. We get basically we loop over each letter in the text. If we find that a letter is in one of those letters that we're actually looking for, we go into these gathered frequencies, we find that letter, and we basically update that counter one more, right, for each of those found letters. So in the end you might have something like 1, 2, 4, 5, 1, for example. And these are all the frequencies of those characters that we found. Now we get our max balloons. They are initialized with infinity, and now we go over each of those letters in the gathered frequencies and their frequency, and we look at when we get the frequency and we divide it by the required frequency for that letter, and we get the floor value, just because if we have like 5 divided by 2, we get 2.5, but we cannot really use 2.5 letters in a word, right? We can only use 2. That's why we floor it. And if this is less than max balloons, we can actually update max balloons. And this is how that happens. So for example, let's go over. We have max balloons at infinity. We see b is 1, right? 1 divided by 1, we get a maximum of 1 possible word with this amount of b's that we found, right? So we update it here because it's less than infinity. We have 1 here. Now the second time, let's even put it, no, I wouldn't. But yeah, the second time, like for the second letter that we see, this is A. We take its gathered frequency, we divide it by the required frequency. So 2 divided by 1 is actually 2, right? So theoretically, we could have had used the letter A in 2 balloon words, but just because we have 2 possible cases doesn't mean we can actually use it twice, because we only have 1 occurrence of the letter B. So that's why this condition here restricts us in updating the max balloons, because 2 is greater than 1, and basically this doesn't ever actually happen. So we are left with 1 in max balloons, and we continue and we do the same thing. 4 divided by 2, 2, but 2 is a bit, we actually have a maximum amount of balloons that's lower than that, so we keep it. 5 divided by 2, 2.5, floor it, it's actually 2. Greater than the maximum amount, we cannot use it. And again, 1 divided by 1 is 1, exactly like the maximum amount, it's basically whatever. And in the end, we are actually left with our maximum balloons. If we never actually found such a case here, for example, I don't know, all of them were 0, I don't even remember. I know I just programmed it this way because I was actually had to talk and program at the same time. It's a bit hard. So in this case, if we for any reason, for example, I don't know, let's just say for any reason we are still left with maximum balloons at infinity, we can just return 0 because we never actually found any meaningful occurrence. And if that's not the case, we can just return max balloons, which would be the last frequency that we actually could pack here, right? And that is all. And as you can see, the answer got accepted, and I was just dumb enough to not record it with audio. But anyway, that was it from me. I hope you learned something. I think this question is not as easy as it seems for my level. I think it's a bit more like a medium-sized question. I couldn't really, like, I had something similar in my mind, but it was like, I was not really sure why I would do this and not something simpler, and it kind of took me some time to actually get myself to do it. But anyway, let's just try and find a solution by yourself. Let's see how you do something like this. And like I said, if you like this content and you're new to the channel, consider subscribing. I hope you learned something, and have a good day. See you next time. Bye bye.